So the fourth term of an arithmetic series is 108 and the 11th term is 80. So let's note this down. So this means that U4 is 108 and U11 is 80. And just remember the general UN formula is always A plus N minus 1 times D, where A is the first term and D is a common difference, yeah? And N is just your position. So just update the formula above. If we got U4, so that's basically A plus, and then 4 minus 1 is 3. So 3D now has to equal 108. Whereas for U11, same thing, it would be A plus 11 minus 1 is 10, so 10D equals 80. So these are our two equations that we're going to have to work with. In fact, we can deal with it right now, because part A tells us to find the common difference D and the first term A. So let's solve this simultaneously. So what we could do, we could subtract the equation. So A plus 10D equals 80 minus the top row. If you subtract them, you're going to get the A's that cancel out. 10D take away 3D is 7D. And then 80 take away 108, that should give us minus 28. And then dividing by 7, you get minus 4. So the common difference is 4. And now to get A, well, just plug in minus 4 back into either one of these equations, yeah? So let's just put over here. So part A, you've got D is minus 4. And then if we substitute to the first one, A plus 3 times minus 4 equals 108. And then make A the subject, yeah? So you're going to have, well, A, so 3 times minus 4 is minus 12 equals 108. A equals 120. Cool, so the very first term, U1, or A, is 120. Nice, so that cancels both of these. Now next one, the sum of the first n terms is Sn. Show that Sn equals 2n times 61 minus n. So first things first, we need to write the general formula for Sn, yeah? So the sum of the first n terms looks like this. It's always n over 2, big bracket, 2a plus n minus 1 times d. Now what do we know? It says that the sum of the first n terms series Sn show that we get this result. Now, because we know the value of a and the value d, we can plug them both in. So let's try out. So therefore Sn equals n over 2. 2 times a is 240 plus n minus 1 times minus 4. Okay. Now what we can do here, just trying to think carefully how we can do this. We can go ahead and expand the bracket. So equals n over 2, 240. If you open it, you're going to get minus 4n plus 4. Okay. We keep on going. N over 2, 240 plus 4 is 244 minus 4n. Now, we can divide it by 2. We can actually expand the bracket and divide by 2. Actually, no, let's see what they want. They wanted 2n. Exactly. So let's go ahead and factorize 4 out of this, yeah? Is 244 going to 4? Yes. If you factorize 4 out, you're going to get 4n over 2. And divided by 4, you get 61, perfect, minus n. 4n over 2 is just 2n. Bracket 61 minus n. And I think we got it. Did we show it? Yes, we did it. Nice. If you've shown this one, then therefore this means that your A and D were actually correct. That's another way to check if your answers are actually good so far. So all this being correct, meaning part A is correct. Now finally, given that Sn is 1100, find the two possible values of n. That should be fine. So just equate your last equation to 1100. 2n, 61 minus n. Okay, so we're going to get quadratic. So let's expand this and move everything to the right side, yeah? So you get 0 equals, well, 2n times 61 is 122n, yep, minus 2n squared, and subtract that, 1100. In fact, I want to make 2n squared positive, so let's move back to the right side. So you're going to get 2n squared minus 122n plus 1100 equals 0. Okay, and then divide that by 2, just make it easier looking. N squared minus, I actually just kept it at the beginning, 61n plus 550. You don't have to do this, but it just helps. So, to solve this one, we need to use either the quadratic formula and get the answer directly, yeah? So the quadratic formula is this. is going to equal minus b plus minus square root. A is your first term in front of the n squared, so it'll be 1. The coefficient, so just 1. B would be minus 61, and C would be 550. So plugging all in, you either get n equals 50 or n equals 11. And to